Okay, so what we're going to look now is question 2. So in this one, we've got the congestion level in a city can also be recorded as a percentage increase in travel time due to traffic congestion in peak periods compared to non-peak. So this is called the percentage congestion level. The percentage congestion levels for the morning and evening peaks periods for 19 large cities are plotted on the scatter plot below. So what we've got is here is the morning, and here we've got the evening. Okay, so determine the median percentage congestion level for the morning peak period and the evening peak period. So median is what we're looking for both, and that was pointed there. So remember, median for our purposes equals the middle number. Okay, so, or the middle position number. So if I've got 19, that means we're after position 10. So we're after position 10. Okay. So basically what we want to look across is, so first off, we're looking for the morning peak period. So we're looking at the morning one. So we're looking from the bottom. So we're going to go across this way. Okay. So I'm going to get rid of some of those. All right, so we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So that one there is our morning. Let's just call it morning so I can label it. Okay. And if I read down, that's going to read down here. And these are in 1% increments, so that's going to be 52%. Look at the evening. So now let's actually get rid of the morning one there. So I'm going to go up. I'm going to go up 1, 2. In this case, it's going to be 3, 4. Probably it's actually 4, 5, 6, 7. 8. Oh, that was the wrong one. That should have been, really, if you look at it, that should be 8, 9, 10. So it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's the 10th one up going in that direction. Sorry, that wasn't probably the best shown way of doing it, but it's the 10th position there. And if I look across, do dot, 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 that's 56. So remember the 1% increments, 56%. So just to show it more clearly, because I'm not sure I showed it, it's like going 1. So I'm looking up here, 2. These are probably equal 3, 4, 5, 6. Then this next one, 7, 8, 9, and this is position 10. Just to make it really clear for you. Okay. So that's what we've got for that part of that question. Okay. All right, let's go next bit. A least squares regression line is fitted to the data with the aim of predicting evening congestion level from the morning congestion level. Okay, so we've got our regression line here. Okay, name the response variable in this equation. So this is going to be a give me. This is a give me mark. It's only worth 1 mark, but this has to be a give me. And when I say give me, it means you should be getting this correct. Because remember, this corresponds to response, and this is your explanatory variables. So these are your variables. Okay, so those are your response and your explanatory variables. And the reason it's give me, this should be in your summary book, so you shouldn't have to worry, even have to really think too much about that one. So when it says name the response variable, we've just highlighted that. That means the answer is going to be evening congestion level. Okay. All right. So let's get rid of some of that for the moment. All right. So that's that mark there. So you got that should be an easy mark for you. Use the equation of the least squares line to predict the evening congestion level when the morning congestion level is 60%. So what we need to do here is use the equation we've got here. I'm going to call it evening congest. I'm going to put like that. I'm just being a little bit lazy to write it all out. Equals, and we look up at our equation up the top here. So that equation up here. All right. So that's going to be 8.48 plus 0.922 times the morning. All right, so I'm running out of room there. I'm not going to write morning congestion level. So it's going to be 8.48 plus 0.922 times. Now, what we said was in the morning congestion level here is 60%. So we're going to put 60 in there. Okay, so that's what we're going to put here. I'm going to put 8.48 plus 0.922 times 60. Okay, and I'll get an answer of 63.8%. Okay. All right, so that is what I'm going to put for that answer there. All right, D. So D is asking for residuals. And if you remember what residuals is looking for, or how you need to calculate that, is basically the residual is equal to Y actual. So again, this should be, oops, I was going to put Y actual minus Y predict. This should be in your summary book. Remember, when we look at residuals, just I'm going to draw it up quickly up here. You've got your line of best fit, and if your dots are here, the residuals is that distance between the lines. So if it's below the line, that would be a negative number. If it's above the line, that would be a positive number. Okay, so that's what you're doing. We're talking about with residuals, and this is how you calculate them. Okay, all right. So Y actual. So let's keep in mind we're looking at the question, and we go, oh, hang on, it's 40. It's morning congestion level at 47%. All right. So what we want for Y actual is we go up to here, and we look at 47. So we go across to here. So that's this one here, and then we go up to that point there and go across, and we see it's 50. So that's a 50. So Y actual is 50. Now, okay, so I just did a little cheat way there on the calculator here, and just so I don't have to type it all out again, because it's the same equation, I'm putting 47. This is the predicted. So it's predicted using your regression line, and I get 51.8. Okay, so my residual is going to be negative 1 minus 8. So 50 minus 51.8 is going to give me minus 1.8. So that would be your residual. Okay, so the value of the correlation coefficient is 0.92. What percentage of the variation in the evening congestion can be explained by the variation in the morning congestion level? So the correlation coefficient is R. What we're after here, so what this is a statement you should have in your variation. You should have a variation that looks like this in your notes anyway, where it was, you might have percentage. You'd have your percentage here, and so percentage of the variation of the response variable can be explained by the variation in the exponential variable, and that's what a statement you should have. So what this is R squared. Okay, so that means I put 0.92, and then I square it and go enter, and I see R squared of 0.8. I'm going to put 6. I'm going to put it all there, because the reason is we have to convert. So what we do is we convert that to a percentage, because we multiply it by 100. So that's going to give us 84.64. It says the nearest whole number, so it's going to be 85%. So my answer is 85%. Okay. And so that's how you'd calculate and complete this question.